Thank you for joining me for another driveway. Today we got a couple little items in here that kind of completes my order, and we're going to take a look at that. And we got the pipes and the tubes and the plate steel and all sorts of parts, cams, springs. We got plenty of stuff to keep rolling on this thing, so we shouldn't have too many shortages of things to do. So let's go check out these pieces I got and play around with them a little bit. Alright, so what we have in the box is, as you can see, a blow-off valve and a wastegate. Let's just start off with wastegate. This is a 50mm VS Racing. Not too terrible. I don't know too much about wastegates. My last turbo, I pretty much just put a spring on there that when the back pressure got high enough, it just pushed it open. That was on a diesel, so it didn't really matter. But this guy here comes with everything you need to get rolling there. It's got these two sides, the top and the bottom. Some of the smaller ones also had a port on the top, but yeah, whatever. These are probably some sort of based on something else knockoff, but as far as I'm concerned, everything works. So in with it, you'll have two springs. What's in there currently is approximately about a 7-pound spring. I'm going to put this one at about a 14. So you have 7, swap this out, then you have 14, or you put both of them in there and you end up with 21. I'm guessing that's what they went with, but I just went down to the smallest one because I plan on doing boost control and that type of stuff, and I want a lower wastegate threshold. And then, like I covered back in that video talking about pipe sizes, the less pressure you go, the bigger your turbo wastegate needs to be. So if you have something that's running really high pressure, like you're running the 20, 25, you can get away with a much smaller wastegate because when it pops open, much more air is going to flow straight out because of that higher pressure. But as your pressure gets lower, you need bigger wastegates to control that lower boost. So that's why I went with this one. This is a 50mm. I don't know if I already stated that, but 50mm. And it comes with your V-bands and all the clamp rings that you need. So it's like, when I first opened it up, I was kind of a little bit lost on how everything works because I couldn't figure out how things would work with this gap in between, and it's like that seemed weird because you'd get a lot of blow-by that and you wouldn't even be able to control boost pressure. Until I figured out it actually has a fire ring seat. So similar to a valve, it seats metal to metal and makes that connection. So you throw that on with your other clamp, then you kind of have this little gap that will clamp when you put the V-band on. There we go, something along the lines of that. That'll be enough to hold all the parts together so I don't lose them, because I'm good at losing stuff. And then on the other side, you've got this other one that seats right in there. Then you just throw its clamp on. But anyways, that's it all installed. Let's just toss the big spring back in the box here. There we go, perfect fit. So then we can jam this thing in there and we can store it. So anyways, the way your boost control is going to work on these is this bottom one is going to be attached to your boost pressure. So that's probably going to come right off the turbine, right into there. And when it builds up to your set PSI level, it will lift this bottom piece. And what you're allowed to do to kind of crutch it up a little bit is you can also put boost pressure in the top here, which would then counteract this and pretty much create higher boost pressures. Most people say it's going to be about twice the pressure. So if you have a 7 PSI, you can go up to 14 on here. But a lot of times you can get away with a little bit more, especially if your boost controller can bleed off the pressure on this one. So if you bleed this so it's open and then put 20 PSI down here, you're going to have an additional 20 PSI pushing down there. So as long as your back pressure isn't higher than the difference between the spring and what you're pushing down here, then you're set. Now, if you want to go even higher than that, you probably end up going with the whole CO2 type of thing, and then you can put as much pressure as you want up here, and then when it reaches a certain pressure, it just lets this side open. So that's pretty much how that works, and we can actually demonstrate this a little bit. Let's just we'll just feed it a little more pressure than it needs. Alright, so that does indeed work, and there's no air leaking on the head side. So I see no reason why it won't work. Anyways, next we got our little blow-off valve. Now, very similar to the other side, it kind of works to bleed off pressure. I'm gonna wager a guess that the O-ring is supposed to go around this thing and bolt to that thing, but I'll figure that out at a later time. But they do give you your ring that's already kind of pre-beveled out to mount on something. So just for a quick reference here, this is just about a 50 millimeter as well. But if you're driving an automatic and doing something like a drag strip, you probably don't need one of these. Where you start running into needing these is if you have tiny turbos on small engines, where the smaller size of the turbo isn't able to take that surge when you let off on the throttle, it can actually snap turbos, bend stuff, but it's especially useful in manual vehicles because every shift that you make in a manual pretty much involves closing the throttle blades. So instead of in between every single shift you're hammering that turbo, this will relieve the pressure. Now it comes with another spring, and that's for fine tuning this so the valve remains closed at idle. So like if it doesn't remain closed at idle, you can suck junk in through that. So you want to have just enough spring pressure to overcome the vacuum. Because once your engine goes back to boost, you'll see boost on this, pushing that back down again, negating a lot of what's pushing here. So that's just about it. We can go demonstrate how this works with a little vacuum. Alright, so I got the vacuum pump hooked up. And you can see we're applying plenty of vacuum, but that valve's not moving. Now when you have pressure from the actual boost side, it'll pop this valve open. So that pretty much shows you that works. Not too shabby. This does have some leakage going through where these threads are. I'm not 100% sure whether that's by design or not. So, kind of hard to tell. But, if it does cause a problem, I can just put some thread sealant in there under vacuum and it'll suck it into the threads. Not a big problem. But anyways, not too bad for that Chinese knockoff stuff. Sure beats $300-400 for a single piece. I mean, when a wastegate starts costing as much as your turbo, you know you're on the wrong webpage. But anyways, that's gonna do it for today. This isn't really a long-winded one. I'm just kind of wading through all the parts I've gotten in the mail and so on and so forth, and kind of creating a attack plan on how to go about this. So, like we do have more parts. We got the Mustang axles in. And then over here, we got a bunch of tube for the manifold and a bunch of straight flat steel for that rear end. So we've got plenty to keep ourselves busy. So anyways, make sure you subscribe if you haven't already. That way you can get to see all this mess, and hopefully I don't go insane and jump off a bridge before then. But anyways, thanks a lot for stopping by, and I guess I will see you guys later.